Good morning, students. Today we will be discussing a very important topic of indefinite integration, and that is called integration by parts.
Sir, I had two doubts in yesterday's DPP.
Okay, so that we can discuss once we are done with this.
Okay,
Okay. Hmm?
yes, yes,
Okay.
yes.
All right. Because as we are starting a new topic, better to concentrate on this, and then we'll come back and discuss those. Okay.
Yes,
And we can take these two questions offline also. After the class also we can discuss.
yes,
Okay.
thank you.
Oh. So if you recall, in our previous class, I mentioned that when you integrate, we make integration by using several methods of integration in a complementary manner. Like that, we have learned how to, use method of transformation. We have learned how to use the method of substitution. Today, we are going to learn how to use the method of by parts. And dear students, that integration by parts is primarily required for when we need to integrate a product of two functions. That means what? So here I'm writing the topic. Integration by parts. So what happens here, dear students, suppose we have two functions. U is a function of x, fx, and v another function of x, suppose it is gx. What we are going to find? We are going to find integration of u into v dx. That means these are the two, functions are actually multiplied fx into gx. So the way we can do it is that we can write this is equal to u into integration v dx minus integration du dx into integration v dx. That complete thing, du dx, that is a function of x, and integration of v dx, that is also a function of x. Now these two functions together dx, and that function's integration. Okay. Let me say once more. I can give you an example that will be very easy to understand. Okay. For example, we have a let me use a different color. We have a function of integration, x into e power x dx. Correct, no? So how to find integration x into e power x dx? So what we can write is that this is equal to, we can write x is u, as if, correct or not?
Yeah,
That x, we are assuming this x as, let me use a different color so that we can assume this x as u, and we can assume that e power x as v. Correct, no, dear student? So then what will happen? Integration x into u into integration v dx, that means integration e power x dx, correct or not?
yeah,
Minus integration du dx. Du dx means what? d dx of x
yeah,
into integration e power x dx. This complete thing is actually multiplied, and then dx. I hope it is clearly understood. Exact use of the formula.
yes,
Correct or not?
yeah,
So then what we get? Then you get x e power x, integration of e power x is e power x. Correct or not?
yes,
Minus integration d dx of x is 1. Again e power x integration. So 1 into integration of e power x is what? E power x.
e power x, yeah.
Correct, na? Dx. plus we are adding one integrating constant called C1. Why? Because we have done that one integration, that e power x. For that one integrating constant comes C1.
Okay.
So that's equal to what? That is equal to x into e power x minus integration of e power x dx. 1 into e power x, no, dear students.
Yes.
So now we know what is the integration of e power x.
E power x
E
t.
power x. So
Yeah.
e power x minus e power x plus c. Why? Because C1 was the previous integrating constant. And
Yeah.
after integration of e power x dx, you will get another integrating constant. So that integrating constant is added with C1 to get a new integrating constant C. Correct, no?
Okay.
So this is what is called integration by parts. Now, there is a very interesting topic. You can say, sir, you choose u into v dx. Now, if I write this thing, that same u into v dx, I can write in this way, na? V into integration u dx.
Mm.
Correct? Because product of two functions is commutative. In
Yeah.
this case, if you say x into e power x and e power x into x, both are same. But
Yes.
next 5 minutes is very important, dear students. So I can write in this way. Then integration, what will happen? dv dx, correct or not?
Yes.
Then integration u dx,
Mm.
then complete dx, correct or not?
Yeah.
But there is a difference between these two. What is the difference, you know? Difference is that when you take this formula, the first one,
Mm.
when you take this formula, that u into v dx minus u into integration v dx minus integration of du dx integration v dx complete dx, in this case, we consider u as the first function, u as the first function, and v as the second function.
Mm.
Okay? How
Yeah.
to remember u is the first function? Because it starts with u. That's why it is a u. U is the function which is getting differentiated. But if you look into the second one, okay, in this case, let me use a different color so that you can always, uh, recall later. So if you do this thing, this formula, formula remains same. But if you use this pattern, then what we can say? We can say v as the first function,
Mm.
okay, and u as the second function. Correct or not?
Yes.
Now the point is that apparently it looks like that, yeah, I can use any of this pattern. I can choose either u as a first function, v as a second function, or I can choose v as a first function, u as a second function. Apparently it appears like that, but it is not. Let's look into this example, what we have done, x into e power x dx. In the x into e power x dx, what we did? We took u as the x as the first function and e power x as the second function, correct or not?
Yeah.
What we did here, we choose, u as the first function, correct or not? X as the first function,
Yes.
x as the first function,
Yes.
and e power x as the second function. Now let's take a different, pattern. That is where we are going to find the integration of x into e power x dx by choosing x as the second function, or the other way, I can write this thing is equal to integration of e power x into x. Both are
Yes.
same, na?
Yes.
So here e power x is the first function. Could you repeat yourself if you never mind? Yeah, thanks. And x as the second function. Now the point is that If we take this approach, let's see what happens. So if we apply the formula, what it will be? It will be e power x into integration x dx
Yeah.
minus integration ddx of e power x
Mm.
into integration of x dx. Correct or not? All of you,
Yes. Yes.
Herman, Sagnik, Devanshu, Srijita, Disha, all of you are able to follow it?
Yes,
Yes.
sir.
Okay. Then what happened is that what we are going to get, e power x, what is the integration of x dx? It is x square by 2. That is x square into e power x by 2
Yes. Yes.
minus integration. It is e power x, ddx of e power x is e power x.
Yeah.
Okay. And integration of x dx is equal to x square by 2 dx. Correct or not? Plus one integrating constant, let's say it is C2. So then what are you getting here? X square into e power x by 2 minus 1 by 2 into integration x square e power x dx plus C2.
Yes.
Now let's focus on this particular, integration. This particular integration is not easy to do. We started with integration x e power x dx. Correct, na? But we landed up with integration of x square e power x dx.
Yes.
That means what? Things are actually going beyond our control. But whereas when you choose the other way, that when you choose x as the first function and e power x as the second function, you see how easily we have done it. This one, we reached the solution very easily. So what is the lessons learned? Lessons learned is that the proper choice of first function and second function is very important to complete the integration. Correct? Now the point is that how to choose first function and second function, and there is a rule behind it. That how to choose the first function and second function. Fine, na? So that I am going to tell you now. So far, any question here to understand that what is the fundamental principle of performing integration by parts? I hope things are clear.
Yes.
Correct, no?
Yeah.
So now I am going to tell you, just the methods. Okay. So let me share the, that particular notes with you. Just give me few seconds. Yeah. My humble request, there is a little background noise by someone. Please take care of it. Either you can mute yourself or this thing, because this is a very important discussion. Everyone should listen to it very clearly, or you can tell that concerned person to stop it for the time being. Thanks. Okay. Now, what we understood here is that method of integration by parts. Let u and v be two functions, and we are going to find the integration of u into v dx. Now the integral of the product of u and v, that is integral of u into v, is given as below. Integration u into v dx is equal to u into integration v dx minus du dx integration v dx. We just discussed this. In the above integration, u is taken as the first function and v is taken as the second function. Okay. It is very important to note that proper choice of first and second function will be very helpful to evaluate the integral. Now, and we have seen by means of an example that improper choice of first function and second function didn't actually give us the solution, whereas the proper choice of first function and second function actually gives us the solution very, very effectively. So here it is a very valid question. Now the question is, how to choose this first and second function. So I am going to tell you some steps, and we need to follow those steps while choosing the first and second function. Dear students, the moment you have selected the first function and second function effectively, 90% of the problem is done. After that, it leads to a very basic integration, most of the cases. So hence, it is very important that we are choosing the first and second function very, very, with due diligence. So how it is going to happen? So here is the rule. Okay. The first rule is that, so here are the steps we need to, you need to follow. So I'm going to, make the notes, relevant notes available to you. Okay. I hope all of you will be able to, view the screen now, right? All of you are able to view it, I hope.
Yes.
Here are the steps. What is the step 1? In the product of two functions, if one function is not directly integrable, okay, and the other is directly integrable, then we can take the function which is not directly integrable as the first function. Let's take an example. If you look into this example, x into integration of x into sine inverse x dx, if you look into this particular integration, so there are two functions. One function is x and the other function is sine inverse x. Now tell me, dear students, between two functions x and sine inverse x, which is not directly integrable? It is sine inverse x, correct or not? You know how to integrate x dx, correct?
Yes. Yeah.
But you do not know how to
Yes.
integrate sine inverse x. So as sine inverse x is the function which is not directly integrable, we take sine inverse x as the first function and x as the second function. That is the first step. So once you get an integration in which the two functions are actually, the product of these two functions is given and you need to perform the integration of that, then first you need to look into it whether out of these two functions, which function is not directly integrable. If that particular one function will be not directly integrable and the other functions would be directly integrable. If this is the case, then you should choose that function as the first function which is not directly integrable. As I give that example, integration of x into sine inverse x dx, here we see the function sine inverse x is not directly integrable. Hence, I will take sine inverse x as the first function and x is the function which is directly integrable. So it will be taken as second function and then you proceed with the formula. Now the step 2. Suppose you get only one function which is not directly integrable. What is the example? Suppose you have been given to integrate sine inverse x dx. Correct? So you should take, in this case, sine inverse x as the first function and 1 as the second function. Because 1 is not directly mentioned, okay, but it means sine inverse x means you can write 1 into sine inverse x. So here is the step 2 then. If there exists exactly only one function which is not directly integrable, then we take it as the first function and 1 as the second function. For example, in the integration of sine inverse x dx, the function sine inverse x is taken as the first function, okay, and 1 is taken as the second function. And then you proceed with the formula. Now the point is that if both the functions are directly integrable, then what to do? like that a function called x into sine x. Here x is also directly integrable and sine x also directly integrable. You know what is the integration of x? It is x square by 2. You know what is the integration of sine x? It is minus cos x. So both the functions are directly integrable. Then what to do? Then there is a rule. What happened to our case? X into integration of x into e power x dx. If both the functions are directly integrable, then the first function is chosen according to the following preference order. What is that? So there are two functions u into v. Remember? Now out of that, which is coming as the first one? U, no? U and v generally functions belongs to the categories of either it is an inverse function or a logarithmic function or a algebraic function or a trigonometric function or an exponential function. Now, out of these two functions, whichever is coming first, that will be taken as the first function. Let's take an example. When we did integration of x into e power x dx, what is x? X is an algebraic function, na?
Yeah.
It is algebraic function. And e power x is what function? It is an exponential function.
Yes.
Correct? Now, out of a and e, which is coming left, the rule is called islet. Okay. Algebraic function is coming before exponential. So we will take that x, which is the algebraic function, as the first function.
Okay.
And this rule is known as islet. Why islet? Inverse, logarithmic, algebraic, trigonometric, and exponential.
Okay.
Again, let's take an example. Integration of x sine x. X sine dx. So x is the algebraic function, correct? And sine x is the trigonometric function. You see, the algebraic function comes before the trigonometric function. So we'll take x as the first function as it is mentioned here. Okay.
Yeah.
Why x is the first function? As it is an algebraic function, and sine x is taken as a second function.
Yes.
Correct or not?
Yeah.
Now, suppose, let me ask you a question, dear students. If we get a, integration something like that, x into log x dx, what shall you do, dear students? Which functions to be taken as first? Which functions to be taken as second?
Log x should be first.
Correct. Because logarithmic function is left of algebraic function. So we should take this, we can write that, okay, should be like this, log x and then x dx. And you take log x as the first function and x as the second function.
Yes.
Correct or not, dear students? All are clear?
Yes.
Okay. So this is all about, integration by parts. Now, before I conclude, I would like to tell you one, before I conclude on the theoretical part, I would like to tell you, if you recall, dear students, in one of our previous classes, I mentioned that if integration is given as an, e power x into a function plus its differentiation, then what we should write? We should write that, if you recall, you will write just directly the e power x into that function plus c. Let me bring that one so that you can recall what I'm referring here. Remember, I gave one problem couple of class back, that is that e power x into sin x plus cos x.
Yes.
Then I said that directly you can write e power x sin x plus c without spending time, right? And that time I told that I will explain why it is so when time comes, right? Now let's start finding that one. So what is the question here in our hand? The question in our hand is that, just a minute. Yep. The question in our hand is that we need to find that e power x fx plus f dash x dx. We need to find integration of e power x into fx plus f dash x. Dear Disha, you able to recall that this we discussed? That
Yes.
yeah. So how it is happening? This is equal to what? This is equal to integration of e power x into fx dx. Correct or not?
Yeah.
Minus, plus integration e power x into f dash x dx.
Yes.
Now let's concentrate on the first integration. Okay. So tell me, out of e power x into fx dx, which one shall be the first function?
F of x.
Why? Good answer. Correct answer. Why?
It's algebraic and that is
How come you
exponential.
know? How come you know it is algebraic? Fx is algebraic. Who said fx?
Um,
That is not the right explanation. But your answer is correct. Justification is not correct.
um,
Anyone can answer why fx should be taken as the first function? The answer is anyone can. Okay. The answer is, sir, nothing is there right to exponential. Correct, no? Then fx has to be any function among inverse, logarithmic, algebraic, trigonometric, no?
yeah. Okay.
That is the justification of why fx should be a first function. Got it, no, dear students? Correct? All of you
Yes.
got it? Sagni?
Yes.
So fx,
Yes, sir.
okay, great. E power x dx minus integration ddx of fx, correct or not?
Yeah.
Into integration of e power x dx, correct or not? That complete integration, recall,
Yeah.
plus integration e power x into f dash x. I hope you all are aware that f dash x means ddx of fx, correct, no?
Yes.
So that is equal to what? We know integration of e power x is e power x. So you can write it is e power x fx minus ddx of fx is what? F dash x, no? And integration of e power x is e power x. So what we get? It is e power x into f dash x dx
Yeah.
plus integration of e power x f dash x dx. Correct? No? Plus c, where c is an integrating constant.
Yeah.
So now that minus e power x f dash x dx and plus e power x f dash x dx integration will get cancelled. So what we'll end up with? E power x fx, e power x fx plus c.
Okay.
Now if you flipped to few of your previous class notes, we discussed a couple of days back that whenever e power x one function plus differentiation of function, that function is there, directly you close your eyes and write e power x fx plus c. One quick example. I can use a different color and I can give that example. Why I'm saying so? Because this will reduce the workload. This will reduce your time to solve that question. E power x, sorry, you get e power x. Then what we get? Sin x plus cos x dx. So here sin x is our, you can assume that sin x is actually fx. Correct, dear students? Then f dash x will be what? Cos x. So cos x is f dash x.
Yeah.
So as we just learned that e power x into fx plus f dash x dx is equal to e power x fx plus c. So it should be e power x into sin x plus c.
Yeah.
Correct, dear students? E power x into sin x plus c. Gurman, absolutely clear? Devanshu?
Yes, sir.
Yes.
Okay, great. Fine. So now what we will do, we will spend time together in solving questions, leveraging integration by parts. And when you are going to find that integration of this, VDX, if I go back to the, theory part, when you are going to, integration of this VDX, there you need to apply based on the integrand, that it is a method of substitution or it is a method of, transformation in a complementary manner. But one thing, it will ensure that it is actually reducing our problem. Got it or not? Clear or
Yes.
not clear?
Yes.
Okay. So now let's start solving problem together. Okay, few problems we should solve together. Okay, and let's see how it goes. Correct, na, dear students? Fair enough?
Yes.
Okay. So the first problem is you will able to get it in another few seconds. I hope you got the question.
Yes.
Okay. So what I want, dear students, is that you first think about that how I can proceed about this question. One of our previous classes, we found this kind of integration, and at that time I told, let's not concentrate how to solve that integration. And now time has come to solve this kind of integration. My humble request, please, there is a background noise by from someone. Please, mute yourself. Thanks. I'll give you 2 minutes, okay? And you need to tell me which one is the first function and which is the second function. And dear students, once you find which is the first and second, after that the problem becomes so simple. It will become very easy to solve. Go ahead and tell me which one is the first function and which one is the second function. Okay, I think I should assist you. Any clue, dear students?
So is sec theta the first function?
Fantastic.
And sec squared theta is the second.
Correct. Very well said.
Yes.
Okay. So, dear students, so how we are writing it? This you can write is that sec theta into sec square theta. Okay. Now, you may think, sir, what leads you to think like this? Just a trial and error method. And after that, let's see, out of these two, which one is directly integrable? Or the other way, which one of these is not directly integrable? We see that sec theta is not directly integrable, correct or not? as sec theta is not directly integrable, okay, we should take this as a first function, correct or not, dear students? Hello?
Yes, sir. Yeah.
Then what we will write? We will write as simple as that sec theta into integration of sec square theta d theta, correct? Minus integration of, let me write as we are doing, few, I should not do any step jump, d d theta of sec theta into integration of sec square theta d theta, then complete, d theta, then complete d theta, isn't it, dear students? So we know what is the integration of sec square theta. What is that? Tan theta. Correct or not?
Yes.
Sec theta into tan theta minus integration of ddx dd theta of sec theta. What is that? dd theta of sec theta?
Tan sec.
Huh? Tell me. Who can say dd theta of sec theta?
So dd sec theta tan theta.
Correct. Say this thing now. So it is sec theta integration of sec theta tan theta into d integration of sec square theta is what? Tan theta?
Tan theta.
D theta, correct or not? So then, and you can write one integrating constant C1 because we have done the integration of that sec square theta, d theta.
Okay.
So that is equal to what? Sec theta into tan theta minus, integration of, tan square theta into sec theta, na?
Yeah.
Integration of tan square theta into sec theta d theta plus C1, that is equal to, as it is, sec theta into tan theta minus tan square theta, you can write is that sec square theta minus 1. I'm so sorry. Just a minute. Let me write properly. Correct or not?
Yes.
Sec square theta minus 1 into sec theta d theta. Correct or not? So plus C1. So now, okay, what we can write is that this is equal to sec theta into tan theta minus integration of sec cube theta d theta plus integration of sec theta d theta. Correct? All of you agree to me?
Yes.
Now, what the question has been given to us to find the value of integration of sec q theta d theta. Correct or not? So let's assume this integration as I. Let I is equal to that integration of sec q theta d theta.
Okay.
Then what we will end up with? It is sec theta tan theta minus I, correct or not?
Yeah.
Plus, you need to tell me what is the integration of sec theta d theta.
Tan.
No.
Oh, sec theta. Tan.
Integration of sec theta d theta, if you recall from your formula, it is ln of mod sec theta plus tan theta. Ln of mod sec theta plus tan theta. Okay. Those who are not able to recall this formula must realize that how important it is to remember formula, despite having the, knowledge how to solve, we will not able to. So what we can write? So this implies we can write I equal to this. This implies we can write I is equal to this. Correct or not?
But so sec theta was directly integrable, right? Then, like, how did we take u as sec
Oh,
theta?
okay. Good question. The point is that then it is a relative measurement. It is directly integrable means what? The formula you can apply this one. The thing is that out of that sec theta and sec square theta, which one is very easy to integrate? Tell me.
Okay, okay, sec square.
In that way, though, all functions are directly integrable in that way if you think, right? Point
Yes,
is that which one is easier to perform directly integrable? Correct. No, but your question is very valid question. I appreciate your question.
I
So then
understood.
what we get? From here we get 2i is equal to, okay, so here one more thing I need to do. I need to change the integrating constant from C1 to C because we have performed the integration of sec theta d theta. Na?
Mhm.
So 2i is equal to what? Sec theta into tan theta. Correct, na?
Yeah,
Plus ln of mod sec theta plus tan theta. So from here we can find the value of I. So what is the I? I means is our given integration sec cube theta d theta. Correct, na?
yeah,
That is equal to 1 by 2 into sec theta into tan theta plus ln of mod sec theta. Achha, here I forgot to give C. Okay, I can give this as C2. So 1 by C2 you can write is at, C. Anyway, you don't need to be, that much of, very meticulous about writing the integrating constant, computing the, integrating constant. You just write C. What is C? C is nothing but C2 by 2, correct, na?
mhm.
So in this way, you find the value of the, integration properly. Any question here, any moment of time, please do let me know.
Yes.
Okay, if things are fine, can you proceed to the next question?
Yes.
Correct? Okay, let's proceed to the next question then. Okay, so here for this question, you need to spend some time and to integrate it. This is, I'm just telling upfront that, you need to think about it, that which one to take as the first function, which one to take as the second function, then you need to proceed. Okay. I hope the question is visible to you, dear students.
Yes.
Okay. First, go through it and do let me know, first, which one is the first function and which one is the second function. You can, if you wish, you can go through the steps also. Okay. If you have not taken a note, I can take back you. If you see, it is only one function, na? Ln of square root of 1 minus x plus square root of 1 plus x. In fact, there is a small mistake I have done. So let me try to eradicate this mistake. So this bracket is not required to have. Correct, na? Just a minute. Let me remove this bracket. Correct. Got it, na? So, yeah. So, anyone can answer this thing, dear students? Anyone? Goodman, Divyansu, Disha, Srijita, Sagnik. Okay. If you look into the step 2, okay, let me take back you to the step 2. Okay, if you look into step 2, what the step 2 says, that if there is exist only one function, correct, na, dear students? If you look into step 2, if there exists only one function which is not directly integrable, then we take it as the first function and 1 as the second function, isn't it? So what will be our first function? Ln of square root of 1 minus x plus square root of 1 plus x. And 1 should be the second function. All of you got it, dear students?
Yes.
Clear now?
Yes.
So now you proceed, please. Okay. I'll give you, couple of minutes and then I'll start discussing the solution. Okay, dear students, so anyone able to proceed? I'd like to discuss this solution now. Anyone able to proceed with this one?
Sir, I did up to a certain step. After that, I don't.
Okay, so now as we know that as we understood that we need to take ln of square root of 1 minus 6 plus square root of 1 plus 6 as the first function. Okay, so what we can do, we can simply write this is equal to ln of square root of 1 minus 6 plus square root of 1 plus x into integration 1 into dx, correct or not, minus integration ddx of ln of square root of 1 minus 6 plus square root of 1 plus x, correct, into integration 1 dx and complete dx, correct or not?
Yes.
Now we know what is the integration of 1 dx, that is x, correct or not? So then what we'll get? We'll get is that x into ln of square root of 1 minus x plus square root of 1 plus x, correct or not? Then, sorry, then minus integration, we need to find ddx of ln. Now let's apply our chain rule. Ln of something, that will be 1 of 1 by, correct or not? 1 by square root of 1 minus x plus square root of 1 plus x, correct or not? So that first we write. Then ddx of square root of 1 minus x. ddx of square root of 1 minus x, if you do, dear students, so it will get minus 1 by 2
Root
into square root of 1 minus x. Okay. And I am not explaining here details because this is not a class of differentiation. For that, you need to follow the other video lectures which is available. And by 1 by 2 into ddx of square root of 1 plus x is 1 by 2 into square root of 1 plus x, correct or not?
Yes.
And integration of 1 dx, that is x, correct or not? X dx. Apparently it looks like, and then we can integrate, we can add one integrating constant c1 because we have done the integration of 1 dx. So what we get? We get x into ln of square root of 1 minus x plus square root of 1 plus x, correct? And then we should do a simplification. If you do the simplification, what you will get is that we can take minus 1 by 2, okay, into integration. If you do this one, x into square root of 1 minus x square minus 1 divided by x into square root of 1 minus x square. I am not going to each and every step because this is simple algebraic simplification. Okay, and you can do it by your own. Clear or not clear?
Yes.
Okay. Now this x and x got cancelled. Okay. So let me give a bracket here so that dx and the previous integrating constant I am keeping intact. So that is equal to x into ln into square root of 1 minus x plus square root of 1 plus x minus 1 by 2, okay, into integration of x into square root of 1 minus x by x into square root of 1 minus x, that is integration dx, correct or not? Plus 1 by 2 integration dx by square root of 1 minus x square, correct or not? Clear or not clear?
Yes.
And there is a standard formula. there is a standard formula for integration of dx by square root of a square minus x square. That value we should apply here. So this is equal to x into ln square root of 1 minus x plus square root of 1 plus x, correct? Minus integration of dx is x minus x by 2 plus 1 by 2. If you apply the formula,
Sine
is
inverse.
sine inverse of x by 1, that is sine inverse of x. And as we complete all this integration, we finally write the integrating constant as c. Got it?
Yeah. Okay.
That is the final answer. Clear or not clear?
Yes. Yes.
Got it?
Yes.
Okay. Now, so what I will give, I'll please note down my statement that you need to complete the DPP 14 of integrals. If you go through the online platform at KonarClasses.com and go for the DPP 14 of integrals, DPP 14 of integrals contains the question related to integration by parts.
Okay.
That you need to solve, and I am going to give you few assignments here that also you need to work on, and that you need to do. Let me know by by Monday, and Mohor, whatever your queries are, please do send me over WhatsApp, and
Okay.
I'll be in touch with you. Okay.
Thank you.
So here are the assignments I'm going to give you now. Okay, so this is the first question. This is the second question, what you are going to get. And this is the third question. So third question, you will be able to get it shortly. Now the point is that you need to solve these three questions, and as I said few minutes back, the DPP 14 from the online test platform. So with this, I would like to conclude the class for today, unless you have any specific question for me. Our next class is on Monday at 9:30. And
Yes.
Mohur, as we discussed, please send me the questions over WhatsApp, and I'll be discussing with you.
Yes. Thank you.
Okay. Thank you very much.
Okay.